All right, y'all, Mrs. Wagner here. We are going to be doing Unit 2, Lesson 1. This is Activity 4, our mass volume relationship. So the last slides, you looked at different sized cylinders, and they had the same density. Each of the pieces had the same density, which would indicate that they are the same material. Okay, so density is a physical property that can help determine the identity of a substance. So if we have a substance with a known density, and then we come across a substance where we don't know its density, we can figure out that density. We can mass it. We can figure out its volume, either doing water displacement, or we could do length times width times height if it is a cube shape, and figure out its volume. And then we use the formula mass divided by volume. So the M over the V is our formula. And you can figure out the density and then compare the density of that object to known densities of objects. And you can help, it can help determine what that substance is. Okay, so that is exactly what we're going to do today. We have an unknown metal here. I have this particular cube, and I'm just going to show you this. You can get some physical characteristics from it right now, as far as its color. Is it shiny, or is it dull? All right, so I have this little cube, and we're going to try to determine its density and then compare it to the metal density chart here and try to determine if it's aluminum, copper, iron, zinc, or lead. Okay? All right, so the first thing that we're going to do is get its mass. So I'm going to turn on our massing scale. All right, making sure that it's at grams and that it's going to read 0. So as soon as I put it on the table, so it's saying hi. All right, I've got to place it on the table here to get it to go to 0. Okay, so there it is at 0 grams. Okay. All right, so now I'm going to place the cube onto the scale, and we can see that it has gone up to 45.9. You can see that a little bit better. Oops, let's get my hands off of it. Well, 45.8, 45.7, we'll let it settle out there. Okay, I'm going to take it off, make sure that I'm back at 0. There we go. And because I did move it, we want to be accurate. Okay, I think we'll go with 45.8. It seems to be that's where it's settling. Okay. Okay, so it's dropped down to 45.7, and it's hovering there. So I'm going to leave it at 45.7. Okay, so we get it, sometimes it changes, and we've got to just let it kind of settle. So it's 45.7. So on our data chart here, we're in slide number 10. The mass is 45.7 grams. Okay, so now for its volume, we are going to do the ruler method here, where we are using the formula length times width times height. Okay, so it's a cube. We're going to be measuring cubic centimeters. So we have length, we have height, and we have width. Okay, so you can see that I've gone across, I've gone up, and I've gone back. Okay, all right, so I'm going to start with the length here. Okay, all right, so length is 2.5 centimeters. Okay, so its length is 2.5 centimeters. I'm just going to write that on a little piece of paper here so I can remember that. All right, it's a cube, so this isn't going to be difficult. I'm now switching it around to be the width. It is 2.5 centimeters again. And its height 2.5 centimeters, which is what is expected since it's a cube, okay? All right, so we take that formula, length times width times height, so 2.5 times 2.5 times 2.5 equals 15.625. So its volume, now we're going to go back into the data chart, and its volume is 15.625, okay? And that is centimeters cubed. So to do the cubed, we're going to do format, text, superscript, put a 3 there for cube. Then to get out of it, we go format, text, superscript again, and that makes my cursor normal again, okay? All right, so density, we know that the formula now is mass divided by volume. So we'll take its mass, 45.7. We're going to divide it by its volume, 15.625, and that is a density of 2.9248. So we'll round it to 2.9, okay? So now we're going to take a look at the density chart here. And we do not see a 2.9, do we? But we do see something that is close, okay? You know, and when we measure, when this cube was cut, all kinds of little factors can play in here on why we might not get an exact density match. However, when we look at the chart, and I also take a look at what it looks like, what color it is, and I can see it's a little bit shiny as well, I'm going to say that's probably aluminum. So it says, according to our calculations, our metal is most likely aluminum. Okay? And that's going to be our best guess based on the density that we got and the way that it looks. So we want to look at also the physical characteristics. Could it be aluminum based on its physical characteristics? Now, obviously, metals can be painted, or they can be go through some kind of chemical change where they might change color, but I don't think that's what happened here. And with our density being as close as it is to what's on the chart there, I'm pretty confident that this is aluminum.